Hi my dear students, welcome back again. Hope you all are busy in preparing for JEE Mains 2025. Here we are with you to support and boost your preparation. In this lecture we will be going with all the JEE Mains previous year questions from the chapter sets and from the years 2022, 23 and 2024. Let's start with question number 1. Let A is equals to set of n belongs to closed 100 to 700 intersection n. So that means we are supposed to take only the natural numbers from closed 100 to 700. Okay, this is our universal set. Let's take such that n is neither a multiple of 3 nor a multiple of 4. Oh my god. So in set A, that is from closed 100 to 700, we have to take only the elements which are neither a multiple of 3 nor a multiple of 4. Then the number of elements in set A. First, let's take the universal set as the natural numbers from closed 100 to 700. So n of u is equals to, n of u will be equals to, how many natural numbers do we have from closed 100 to 700? So how do we get it? 700 minus 100, that is 600, add 1 to that. So number of natural numbers from 100 to 700, 100, 101, 102 and so on till 700 is 601 natural numbers. Okay, now in this 601 natural numbers, we only need the elements, we only need the natural numbers which are neither a multiple of 3 nor a multiple of 4. Okay, for that we'll take two sets, friends. Let set x denotes only the elements which are multiples of 3. And set y denotes only the elements which are multiples of 4. X denotes multiples of 3, y denotes multiples of 4. Now, what do you mean by x union y? X union y indicates a set which are either a multiple of 3 or a multiple of 4. But actually what we need? We need A. A is a set such that which neither includes multiple of 3 nor includes multiple of 4. That means clearly our set A is nothing but the complement of this universal set. Complement of this union. Complement of this. Correct na? So set A is nothing but x union y whole complement. Okay. So n of A is equals to what is x union y whole complement? Universal set minus x union y, that is n of u minus n of x union y. Now in general, what is n of x union y? From cardinal theorem, n of x union y is equals to n of x plus n of y minus n of x intersection y. N of x plus n of y minus n of x intersection y. Clear? First, let's find out what is n of x. N of x denotes the number of multiples of 3 from closed 100 to 700. So let's see, first, before we find n of x, let's find what are elements in set x. So what are all the multiples of 3? Starting with 102, because 102 is the first multiple from 100, which is a multiple of 3. 102, 105, 108 and so on. The last multiple will be 699. 699 is a multiple of 3. Clear? So to get how many number of multiples, for that what we do? We just divide by 3, boss. If you divide 102 by 3, how much do we get? 3 1s are 3 3s are 9. 3 3s are 9. 3 4s are 12. So this is 34th element. Next, this is divide by 3. So 3 2s are 6, 3 3s are 9, 3 3s are 9. So that is 233 minus 34. So number of elements in x will be equals to 233 minus 34 plus 1. 233 minus 34 plus 1. As I said, sir, why you are adding 1? Because to get number of multiples of x, number of elements in this set x, it starts with 34, 35, 36 and so on till 233, no? So to get number of elements, 233 minus 34, add 1 to that. Okay, so 234 minus 34, which is equals to 200. Clearly, number of elements in X is 200, friends. Now, what Y indicates? Y indicates multiples of 4. Multiples of 4. What are the multiples of 4? From close to 100 to 700, starts with 100, 104, 108, and so on, till even 700 is also a multiple of 4. So to get number of elements, just divide by 4, friends. 4 ones are 4 25s are clear. Next, divide this 700 also by 4. 4 ones are 4. Next, 4 sevens are 28. 4 5s are 20. Clear? So to get number of elements in Y, that is 175 minus 25 plus 1. 175 minus 25 is 150. 150 plus 1 is 151. So there are total 151 multiples of 4 in the set close to 100 to 700. Friends, this is what very important. Sir, why you are excluding X intersection Y? Because when you are adding the number of multiples of 3 and number of multiples of 4, all the multiples of 12, all the multiples of 7. See, 108 is common. You are adding 108 in this and this. So this 108, that means all the multiples of 12 are added twice. So you subtract them for once. That is, X intersection Y are nothing but multiples of 12. So multiples of 12 are 108. Next, plus 12, that is 120, and so on. Last multiple of 12 is 696. Now divide this also by 12 to get number of elements. So 12 ones are 12 nines are 108. 12 nines are 108. 2 divide by 12. How much do you get? 12 ones are, or 6 twos are 12. 6 ones are 6. 6 ones are 6 again. 6 6 are 36. Again 2 divided by this is 2 5s are 10. 2 8s are. So we have got 58. Now number of elements in X intersection Y will be, number of elements in X intersection Y is equals to 58 minus 8, 58 minus 9 plus 1. So 59 minus 9 is 50. There are total 50 elements in the X intersection Y. So that's it, friends. Now required number of elements is, first we'll find X union Y. So what is our X union Y? X union Y, number of elements in X union Y is equals to number of elements in X 200, number of elements in Y that is 151 minus 50. So this is 351 minus 50, which is 301. Okay, so number of elements in A is nothing but total 601 minus 301, which is equals to 300. So the answer is option B, friends. So the total number of elements in the set close to 100 to 700, which is neither a multiple of 3 nor a multiple of 4, is number of elements will be 300, friends. Clear? Next question. So this is also from 2020-24. Let S is equals to set of X such that X is a real number. Root 3 plus root 2 whole power X plus root 3 minus root 2 whole power X is equals to 10. Then the number of elements in S is, number of elements in S. Friends, these two are conjugates. Okay, so we can write 1 by root 3 minus root 2, like root 3 minus root 2 as 1 by root 3 plus root 2. Root 3 minus root 2, we can see root 3 minus root 2, if you rationalize it, multiplying and dividing by root 3 plus root 2, you get 1 by, see, a plus b into a minus b, a square minus b square, 3 minus 2, 1 by root 3 plus root 2. So clearly we can say root 3 minus root 2 is 1 by root 3 plus root 2. Clear? Now we have root 3 plus root 2 whole power x plus 1 by root 3 plus root 2 whole power x is equals to sum 10. Okay, now we do one thing, friends. Let's take root 3 plus root 2 whole power x as some p. Whole power x as some p. So we get p plus 1 by p is equals to 10. That means p square minus 10p plus 1 is equals to 0. A quadratic equation. So we can solve roots here. P is equals to minus b plus or minus root over b square 100 minus 4 divided by 2. 100 plus or minus 100 minus 4 is 96. Root 96 divided by 2. Now, so root 96 is nothing but 12 8s are 96. So for that, what we can do? 12 8s are 96. We can write this 12 as 4 into 3 and 8 as 4 into 2. So this we can write it as 10 plus or minus 4 root 6 divided by 2. That is clearly 5 plus or minus 2 root 6. Okay, we have got the value of p as 5 plus or minus 2 root 6. So what is p actually now? P is root 3 plus root 2 whole power x is equals to 5 plus or minus 2 root 6. 5 plus or minus 2 root 6. That means root 3 plus root 2 whole power x can be either 5 plus 2 root 6 or 5 minus 2 root 6. So clearly x will be equals to log 5 plus 2 root 6 to the base root 3 plus root 2 or x is equals to log 5 minus 2 root 6 to the base root 3 plus root 2. Let's see this, friends. First, log a to the base b is defined only when a comma b greater than 0 and b not equals to 1. Okay. Now see this. Is 5 plus 2 root 6 positive? That means x exists. So a real value of x exists. Is 5 minus 2 root 6 exist? Yes, exist. Root 6 value is something 2 point something. 2 into 2 point something is less than 5 only. Less than 5 only. Or we can write this 5 minus 2 root 6 as 5 minus 2 root 6 as root 3 whole square plus root 2 whole square minus 2 into root 3 into root 2. This is clearly root 3 minus root 2 whole square. Square of something. Square of something. So for sure it is positive. Okay. So this is positive to the base. Positive means this is also belongs to capital R. So there exist two real values of x which satisfies this equation, friends. Which satisfies this equation. The answer is option B. Clear? Next question. Let capital A and capital B be two finite sets with m and n elements respectively. The total number of subsets of set A is 56 more than the total number of subsets of B. So for a set consisting n elements, number of subsets is 2 power n. So what they said, the total number of subsets of set A is 56. Set A has m elements. So total number of subsets of set A is 2 power m. Now this is equals to 56 more than total number of subsets of B. Set B has n elements. So total number of subsets in B will be 2 power n. Done. Now they are asking first we have to find m comma n. In all such cases, first get all the 2 raised to terms on the left hand side on one hand. So 2 power m minus 2 power n is equals to 56. Take 2 power n common. 2 power n of 2 power m minus 1 is equals to 56. Friends, now you have to express this 56 as a product of two numbers such that 1 is the exponent of 2, okay, into other number should be exponent of 2 something minus 1. Clear? So this we can write it as 56, we can write it as clearly 8 into 8 minus 1. 8 into 7, 7 is 8 minus 1. So 8 into 7, 8 minus 1. 2 power m into 2 power m minus n minus 1. So clearly 2 power m should be equals to 8 and this 2 power m minus 1 is 7. If 2 power m is equals to 8, that means m is equals to 3. Done. So now this 2 power m minus n is again equals to 8 because 7 means 8 minus 1, no? So 2 power m minus n should be equals to 8 which is 2 cube. m minus n is equals to 3. M minus n is equals to 3. Friends, this is 2 power n. This is 2 power n. So here we have got the value of 2 power n, friends. 2 power n. So 2 power n is equals to 8. N is equals to 3. That means we have already got n is equals to 3. Let's just substitute here. M minus 3 is equals to 3, which implies m is 6. Fine, we have got point P now. Point P is m comma n, which is 6 comma 3. Q is given. Q is minus 2 comma minus 3. They are asking distance between 2 points. PQ. So what is PQ now? Square root of 6 plus 2. 8 square. 64. 64 minus 2 comma minus 3 it is. 3 minus 3 minus 3. 3 minus of minus 3, which is again 6. 6 square is 36, friends. Root over 64 plus 36 is 100. Root 100 is 10. So the distance between these 2 points is 10 units. Clear? Simple question. Actually, the question is only till here. If you can get m comma n values, distance between P and Q is simple. Next question. An organization awarded 48 medals in event A. Okay. 25 in event B and 18 in event C. If these medals went to total 60 men and only 5 men got medals in all the 3 events, fine. Then how many received medals in exactly 2 of the 3 events? Exactly 2 of the 3 events means exactly 2 elements. Exactly 2 elements. Actually, so exactly number of elements we need exactly 2. Exactly 2. That means exactly 2 means n of A intersection B plus n of B intersection C plus n of A intersection C. This is 2 or even 3 also. Okay. But we need exactly 2 means only this part we need, friends. Only this part. So only this part we need. That is now to get this particular part, what we need? See, when we say when you are adding n of A intersection B, you are adding this n of A intersection B intersection C is added in this and in this. So it has to be subtracted thrice. That means this should be equals to minus 3 times of n of A intersection B intersection C. Clear? Now what else we need? A, B, C we have. 5 men got. Now what we need? So already they have given. So this is nothing but sigma n of A intersection B minus 3 times of n of A intersection B intersection C is anyhow 5 men got medals in all the 3. So 3 5s, this is n of A intersection B intersection C is 5, friends. So 3 5s are 15. So 15. This is what our required. Now chalo. Now went to total 60 men. So we know n of A union B union C is equals to n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of A intersection C. That we can write it as minus sigma n of A intersection B plus n of A intersection B intersection C. Okay. So this they have given 60 is equals to n of A plus n of B plus n of C. 48 plus 25 plus 18. 18 minus sigma n of A intersection B plus n of A intersection B intersection C is this. So to get sigma n of A intersection B is equals to 48 plus 25 plus 18 plus 5. That is 48 plus 30. 48 plus 30 plus 18 minus 60, friends. So 30 minus 60 is minus 30. Minus 48 minus 30 is 18. 18 plus 18 is 36. So this value is 36. Now what we require? This minus 15. That is required is 36 minus 15, which is equals to 36 minus 15, which is equals to 21. Answer is option C. So how many received medals in exactly 2 of the 3 events? In exactly 2 of the 3 events. In at least 2 events, if they say, that means this one, this sigma n of A intersection B. Clear? So that becomes the correct answer. Next question. Let sigma be the sample space and A is subset of omega. Be an event. Given below are 2 statements. Friends, actually this symbol is ohm, we can say. In resistance we have seen this already. Okay, we can call it as ohm. Let ohm be sample space and A subset of or equals to ohm be an event. Given below are 2 statements. If P of A is equals to 0, probability of occurrence of an event 0 means, what do you mean? Actually P of A is nothing but n of A divided by n of S. If P of A is 0, that means there exists no element in our favorable set, correct? N of A is 0. Okay, so that is nothing but n of A 0 means A is a null set. So first statement is true. Next, if P of A is 1, that means n of A is equals to n of S. N of A is equals to n of S. So that means A is equals to sample space only. Clear? A is equals to sample space. So clearly both S1 and S2, both the statements are true. Both the statements are true. Next. They have given a set S is equals to set of X belongs to closed minus 6 comma 3 minus set of minus 2 comma 2. Okay, we have to exclude minus 2 comma plus 2 from closed minus 6 comma 3. Done. Now what we need? And T is equals to something. Then the number of elements in S intersection T. What are all the elements which are common to S intersection T? Friends, if they have not given anything, that means set of real numbers only. So from closed minus 6 to 3, set of real numbers. Intersection this integers. Okay, so we'll take only integers. So that means we'll see this now. Chalo. If a ratio A by B is positive, friends, if a ratio A by B is positive, it happens only in 2 cases. One case is both positive or both negative, because positive by positive is positive. Negative by negative is again positive. Clear? So both A comma B positive or both A comma B negative. So we'll split it into 2 cases, friends. We'll split it into 2 cases. Case 1. Case 1. That is both positive. Mod of x plus 3 minus 1 should be greater than or equals to 0 and mod x minus 2 should also be greater than or equals to 0. Clear? And case 2 is this less than or equals to 0. Sorry, denominator should never be equals to 0 because it is in denominator. Okay, so that means mod of x plus 3 greater than or equals to 1. If mod of x plus 3 greater than or equals to 1, that is x plus 3 less than or equals to minus 1, or x plus 3 greater than or equals to 1, and along with this mod x greater than 2, which implies x less than 2 or x less than minus 2 or x greater than plus 2 by modulus definition. Now from here we can say x less than or equals to minus 4 or x greater than or equals to minus 2. So actually see this, friends. First I'll take the number line for this. Minus 4 minus 2 greater than this one, less than this, greater than this. Okay, and what about this one? Let me take this as x less than minus 2, less than minus 2. So open brackets, less than minus 2 and greater than 2. We have somewhere greater than 2. This is also open brackets. Now what is the common region in both? We have to take common. Why? Because it is and. So clearly x belongs to from where? Closed minus 6 to closed minus 6 to closed minus 4. Minus 4 is also included. Union union open to actually we have only till 3, no? So open to till close to 3. This is our case 1 solution. Now case 2 is both less than or equals to 0. Both negative. So mod of x plus 3 minus 1 less than or equals to 0 and mod x minus 2 is less than or equals to 0. Friends, if you do this, you are getting no solution. Just give a try. No solution in this. No solution in this. Because mod of x plus 3 less than or equals to 1 and mod x less than or equals to 2, it never happened. If you want, you can just use the same modulus principle and do this. Okay. Now, I did it directly. This is the solution set of yes. Now, this is our yes, friends. This is our yes belongs to this one. Okay. This is our set yes. Now, what we need? We need t. So, t is clearly x square minus 7 times mod x plus 9 less than or equals to 0. Here also we have modulus. So, mod x can be split into 2 cases, correct? If x less than 0, mod x will be equals to minus x. Okay. So, in this case, x square plus 7x plus 9 less than or equals to 0. Just will take x value minus b plus or minus root over b square minus 4ac. 49 minus root over b square. 49 minus 36 divided by 2. So minus 7 plus or minus 49 minus 36 is 13. Root 13 divided by 2. So clearly minus 7 plus or minus root 13 value is 3 point something. Let's say some 3.5. Let's say approximately 3.5 divided by 2. So this less than or equals to 0 means minus 7 minus 3.5 is minus 10.5. Minus 10.5 divided by 2 is minus 5.5. So from minus 5.5 something, minus 10.5 divided minus 5 point something to minus 7 plus 3.5, that is minus 3.5. Minus 3.5 by 2 is minus 1 point something. Minus 1 point something, minus 1.75 something. So from minus 5.5 to minus 1.7.5, what are the integers do we have? See, this is minus 5, minus 6 and minus 1, minus 2. Clearly, minus 5 point something will lie here, minus 1 point something will lie here. So what are all the integers do we have in between these two? Minus 5, minus 4, minus 3, minus 2. Clear? Minus 5. So we can take integers in this as minus 5, minus 4, minus 3, minus 2. Okay? Now, in the same way, if suppose case 2, friends, x greater than 0, mod x is equals to plus x, no? So x square minus 7x plus 9 less than or equals to 0. Okay? Now x it takes 7 plus or minus root 13 divided by 2. That is 7 minus root 13. 7 minus 3.5 is 3.5 by 2. That is 1.75 something to 7 plus 3.5, 10.5. 10.5 divided by 2 is 5 point something. Now from 1.75 to 5, what are all the integers do we have? 2, 3, 4, 5. That's it. 2, 3, 4, 5. Okay. Now, what are all the integers that we have common in both this and this? In this and this. So clearly we have minus 5, minus 4 we have, minus 5, minus 4. We don't have minus 3. Chalo. Next from open 2 to close to 3 and only 3 we have. Correct? Only close to 3, here minus 5, minus 4. That's it. So these are the 3 integers, number of elements in S intersection T. So there are only 3 common elements in both S and T. That is n of S intersection T is 3, friends. This is numerical type question. Okay. Next. Let A is equals to set of x belongs to R such that mod of x plus 1 less than 2. Mod of x plus 1 less than 2 means minus 2 less than x plus 1 less than plus 2, that is minus 3 less than x less than 1. So x belongs to minus 3 to 1. Second question, second one. Set B is nothing but mod of x minus 1 greater than, mod of x minus 1 greater than or equals to 2 means x minus 1 less than or equals to minus 2 or x minus 1 greater than or equals to plus 2. So x less than or equals to minus 1 union, that is r, x greater than or equals to 3. Okay, so in this case x belongs to minus infinity to minus 1 closed, minus 1 closed, union closed 3 to infinity. This is set A, this is set B. Now see this friends, let's try to represent both on this number line. Let's try to represent both on this number line. We'll see minus 3 somewhere here, minus 3 somewhere here, then minus 1, 1, 3. First set, open minus 3 to minus plus 1. Second set is clearly closed this one and closed 3 to infinity. So this is the set. Okay, white one is set B, yellow one is set A. Now first one, A minus B. From A if you exclude B, from A if you exclude B, it is clearly open minus 1 comma 1. Yes, A is correct statement only. B minus A, from B if you exclude A, from B if you exclude A, only this portion to be excluded, no? So that is minus infinity to minus 3 open, union closed 3 to infinity. This is B minus A. But they have given in another form, that is, so clearly it is R minus, from R what we exclude, closed minus 3 to open 3. So this is B minus A friends, closed minus 3 to closed minus 3. Anyhow, actually closed minus 3 can be a part here because minus 3 is not part of A. So clearly R belongs to open minus 3 to open 3. Open minus 3 to open 3. But they have given open minus 3 comma 1. So this is the false statement. So hence this is our answer. Our answer is option B. They are asking us to pick up the false statement. So hence option B is false. Clear? Next question. Out of all the patients in a hospital, 89% are found to be suffering from heart ailment, heart disease. 98% are suffering from lung infection. K% of them are suffering from both the ailments. First, N of H denotes people suffering with heart ailment. So N of H is equals to 89%. Let's take 89. Next, out of total 100%, means total is N of universal set is 100. Next, N of lung infection is something 98 given. K%, we see friends, generally N of H union L is equals to 89 plus 98 minus N of H intersection L. Okay, so if union, see, union will always be less than or equals to 100. This will always be less than or equals to 100 because universal set, this union will always be less than or equals to universal set. Universal set is 100, no? So in that case, that is N of H intersection L is equals to 89 plus 98 minus 100. This is maximum value. Okay, so N of H into 89 plus 98 will be 187 minus 100. Okay, so for sure 187 minus 100, that means N of H intersection L will always be greater than or equals to 87. Will always be greater than or equals to 87. And intersection, for sure it will be less than or equals to, the maximum value of intersection will be always less than or equals to the individual sets. It should be less than or equals to 89 and less than or equals to 98. So this is the least, so that means n of h intersection L will always less than or equals to 89. So it can either be 87 or 88 or 89. H intersection L can take either 87% or 88% or 89%. Now what they are asking, then K cannot belong to the set. So we have to exclude an option which is not containing 87, 88 and 89. 87, 88 and 89, which is option A. In option A, we don't have any 87 or either 88 or 89. Okay. Next question. In a survey of 220 students of a higher secondary school, this is total. Okay. N of S, sample space, is equals to 220 of a higher secondary school. It was found that at least 125 students and at most 130 students studied maths. So maths, at least 125, at most 130. So number of students who have studied maths will be ranging from 125 to 130. Okay, this should be the first set. Next, number of students who have taken physics is 85 to 95. 85 less than or equals to 95. Now, next physics, next chemistry. Coming to chemistry, how many students? At least 75 and at most, so 75 to 90. Chalo. Then what we need? 90. Chemistry, 30 studied both physics and chemistry. So PC is equals to, PC means physics and chemistry, is equals to 30. Both chemistry and maths, chemistry, MC denotes chemistry and maths, that is equals to 50. Next, what we need friends? 40 studied both maths and physics. Let's say MP is equals to 40. 10 studied none of these three subjects. None means A union B union C whole complement is equals to 10. A whole complement is nothing but N of S minus N of A union B union C is 10. So N of S is anyhow 220 minus 10. Clearly N of A union B union C is equals to 220 minus 10, which is 210. We have got N of A union B union C value. At the same time, sigma n, if you add all of these three, 125 plus 85 plus 75 is 285, less than or equals to, sigma m means m plus p plus c, 130 plus 95 plus 90, 90, 180 plus 130. So that means 315. So this value for sure it will be always less than or equals to, lie in between 285 to 315. Now what we need? Chalo, N of A union B union C, friends, N of A union B union C is always equals to this sigma m minus sigma MP, that is sigma P intersection C minus sigma M intersection C minus plus N of M intersection P intersection C, that is MPC, N of MPC. So 210, that is we need this, no? So 210 plus sigma MP minus sigma M is equals to number of students you have taken who have studied both all the three. 210 plus sigma MP, first we'll add these three. 30 plus 50, 80 plus 40, 120. Okay, so 210 plus 120 is 330, friends. Okay, chalo now. Okay, first the maximum value N of MPC, the maximum value of M intersection P intersection C is the minimum of these three, because the intersection of all the three should always be less than or equals to intersection of 2. Okay, so the maximum of this should be equals to the minimum of these three, friends. Minimum of these three. What is the minimum of these three? 30. So n of MPC will always less than or equals to 30. So that means M and N be the, so at most indicates, let M and N respectively be the at least and at most. So N is equals to 30 we got. N is equals to 30. Now minimum we need at least means, see the maximum value of these two is 315. So to get the minimum, N of MPC minimum 330 minus 315, that means is always greater than or equals to 330 minus 315, which is 15. So this is the minimum value of this. Minimum means M is equals to 15. M 15, N 30, then they are asking us to find M plus N value, that is 30 plus 15, 45 is the answer. Clear? This was asked in 2024, 4th April, first shift. Next question, friends. If S is equals to set of all real numbers such that mod of 2a minus 1 is equals to 3 times step of a plus 2 times fractional part of a, where t denotes the greatest integer or fractional part, then 72 times sigma a belongs to a sigma a they have given. Okay, let's see. First, we all know every real number x is equals to step of x plus fractional part of x, correct? Okay, now we can write this 3 times of step a as 2 times step a plus 2 times fractional part of a plus box of a. 2 times a, if you take 2 common, that is 2a, friends. 2a plus box of a now. So this is clearly 2a plus step of a. Okay. Now let's take 2 cases. Suppose if 2a minus 1 is less than 0, that is a less than 1 by 2, then mod of 2a minus 1 will be minus of that. Minus of 2a minus 1 is 1 minus 2a is equals to 2a plus box of a. Now when a is less than 1 by 2, if a less than 1 by 2, something like 0.4. What is step of 0.4? 0 only. So 1 minus 2a is equals to 2a, 4a is equals to 1, a is equals to 1 by 4. Chalo, we got. That's it. Now if 2a minus 1 is greater than 0, friends, a is greater than 1 by 2. Okay. Now see this, a greater than 1 by 2. 2a minus 1 is equals to 2a plus box of a. 2a gets cancelled, box of a is equals to minus 1. When a is greater than 1 by 2, step of a should always be greater than or equals to 0. Greater than or equals to 0. So how can it be negative 1? So not possible. Not at all possible. So if it is not possible, that means set S is nothing but only one element, which is 1 by 4, friends. So what do we need? Required is 72 times sigma all the elements of set S. Only one element. So 72 divided by 4, which is 18. Answer is 18, friends. Next question. The number of elements in the set S is equals to set of ordered pairs of xyz. Xyz are integers. Okay. XYZ are integers, x plus 2y plus 3z. Oh, acha, integers and greater than or equals to 0. That means only non-negative values. We have got now x plus 2y plus 3z is equals to 42, and x, y, z all should be greater than or equals to 0. So in this case, friends, we can do either by using binomial theorem or just by using simple sets concept only, algebra concept. Suppose, friends, if z is equals to 0, then we get x plus 2y is equals to 42. If x plus 2y is 42, the value of y can take 0, 1, 2, 3, 4 and so on till 21. Y can take 0. Y can take, see, y, if y takes 0, x will be 42. If y takes 1, x will be 40. In that way, if y is 21, x will be 0. Y can't go beyond 21, because if y takes 22, x will be negative. we don't want xyz should always be greater than or equals to 0. So y takes all the integers from 0 to 21. So that means in this case, how many solutions we get? Number of solutions. When z is 0, we get 22 solutions, friends. Because for each corresponding y, we'll get one corresponding x also. So total 22 solutions we get. Next, if z is 1, x plus 2y is equals to how much? 42 minus 3, which is equals to 39. So y can take from 0, 1, 2 and so on. 19 2s are 38, till 19 we can take. So that means 20 solutions we get in this case. If z is 2, x plus 2y is equals to how much? 3 2s are 6. 42 minus 6 is 36. Now 36 means y can take from 0, 1, 2 to 18, because 18 2s are 36, no? So total 19 solutions we get in this case. Z is equals to 3. X plus 2y is equals to 3 3s are 9. 42 minus 9 is 33. 33 means y can take from 0, 1, 2, 2 to 2 12s to 30, 2 16s. So till 16 it can take. That means till 16 it can take. So 16 plus 1, 17 solutions we get. Clear? Here also 20 solutions. Y is equals to 19. 19 to 38. Fine. Next, z is equals to 4. If z is equals to 4, what happens? Then z is equals to 4. 4 3s are 12. 42 minus 12 is 40. X plus 42 minus 12 is 30. X plus 2y is equals to 30. So y can take from 0 to 15, which includes 16 solutions. Okay, so in that way, friends, in that way, if we keep on going, then z is equals to till where we can take z is equals to 14. Till z is equals to 14 we can take, because if we take z 15, 15 3 is 45. If z is equals to 14, 14 3s are 42. X plus 2y is equals to 0. So that means y can take only 0. We get only one solution. From here to here we'll get total 169 solutions we get, friends. Total 169 solutions we get. Clear? Next question. Let the set C is equals to set of ordered pairs of x comma y such that x square minus 2 power y is equals to 2023, where x and y both are natural numbers. Sigma sum of all the elements of x plus y. Sum of the ordered pairs x plus y they are asking. Let's see this, friends. First, we can write 2 power y is equals to x square minus 2023. 2 power y is equals to x square minus 2023. If you observe this, friends, it is only true only for one number, that is x is equals to 45, which implies x square is equals to 2025. 2025 minus 2023 is the only exponent of 2 that we have, that is 2 power y is equals to 2025 minus 2023 is 2 power 1. So if x is 45 implies y is equals to 1, and 45 comma 1 is the only element which is C has. That's it. No, for no other element it is going to be true. Okay, now what they are asking us to find, sigma x comma y belongs to C, x plus y, only one element. So x plus y is equals to 45 plus 1 equals to 46. Answer is 46. Clear? Next question. A group of 40 students appeared in an examination of 3 subjects, maths, physics and chemistry. Just now we have seen a similar type of question. It was found that all students passed at least in one of the subjects. Acha, that means n of A union B union C is equals to 40. N of MPC, M union P union C is 40. Okay. It was found that all 20 students passed in maths, So maths 20 students, physics 25, chemistry 16 students. At most 11 students passed in maths and physics. At most. So that means MP is always less than or equals to maths and physics at most 11. Physics and chemistry at most 15. Next, chemistry and maths, MC, is again less than or equals to 15 at most. M intersection P. The maximum number of students passed in all the three subjects, M intersection P intersection C. Friends, actually if we draw Venn diagram, universal set is equals to union, because all of them at least one student is appeared in all the subjects. So that means passed in one of the C subjects. Then fine. Now let's see. They are asking maximum number of M intersection P intersection C. Let's take it as X. They have given this as 11, friends. This total is 11. So only this portion is 11 minus X. This portion will be 15 minus X. And this portion will be also 15 minus X. This is M, P, C. Okay. Now, very simple, friends. See, each of them 11 minus X should be greater than or equals to 0. Yeah. 11 minus X should be positive. 15 minus X greater than or equals to 0. So 11 minus X greater than or equals to 0 means X minus 11 less than or equals to 0. X is less than or equals to 11. So the maximum value of X can be 11. But if X is 11, friends, if X is 11, this portion becomes 0. This portion becomes 0. So the what can be the beyond 11, as X is less than or equals to 11, before 11 we have X equals to 10. So the maximum value of X can be 10. Very simple. The maximum value of X can be 10. Why? Because if X is 11, this portion is becoming 0. This portion is becoming 0. Clear? So it was found that all the students passed in at least one of the subjects as they have given. This portion should not be 0. So 11 minus X, X minus 11 should be less than or equals to 0, but X can't be 11. Why? Because if X is 11, this portion is getting 0. So next to 11 we have 10. So the maximum value of X can be 10. So the maximum number of students passed in all the three subjects is 10. X is equals to 10. Next question. The number of elements in the set n belongs to Z such that n square minus 10n plus 19 less than 6 mod of n square minus 10n. This we can write it as, see friends, n square minus 10n. Let's do it by using completing square method, plus 25, because n minus 5 whole square, we can write this as n minus 5 whole square. We have 19, no? So minus 25, that means we'll do one thing. N square, we have added 6 and subtracted 6. So n square minus 10n plus 25. We need only 19, no? So minus 6. Mod of this is less than 6. Okay. This value can be written as n minus 5 whole square minus 6 less than 6. So that means minus 6 less than n minus 5 whole square minus 6 less than plus 6. Now add 6. So 0 less than n minus 5 whole square less than 12. N minus 5 whole square less than 12 means n minus 5 can't be 0. It can be either plus or minus 1 or plus or minus 2 or plus or minus 3, because 1 square, n minus 5 is 1. 1 square is less than 12, minus 1 or less than 12, plus or minus 2 or plus or, if I take 4 means 4 square 16. So that means n is equals to, if it is 1 plus 5, 6, or minus 1 plus 5 is minus 4. Next, 2 plus 5, 7, or minus 2 plus 5 is minus 3. Next, 3 plus 5, 8, or 3 minus 3 plus 5 is minus 3 plus 5. 3 plus 5, 8. Minus 3 plus 5 will be plus 2. I mean, all are plus only, friends. Minus 1 plus 5 plus 4 plus 3 only. So n can take 2, 3, 4, 6, 7, 8. How many number of elements in n they are asking. So that means 2, 3, 4, 6, 7, 8. The number of elements in this set is 6 elements. Clear? Next question. The number of elements in the set almost the same. 3 power n minus 3 is a multiple of 7. That means 3 power n minus 3 should be equals to 7k. 3 power n minus 3 should be equals to 7k. Now let's see this, friends. 3 power n to be so 3 power n should be equals to 7k plus 3. 7k plus 3. So that means for which are all the values it could be true. First thing, if k is equals to 0, 3 power n should be equals to 3. That means n is equals to 1. Okay. If k is 2, 7 2 is 14. 14 plus 3, 15. No. If k is 3, no. So the next value which is true for is 7. 1, the difference is 6. 7 plus 6 is 13. 13 plus 6, 19. 19 plus 6, 25. And so on it goes. And so on till 100 we need to take. So n value should only be from 13 to this one. Okay. So now number of values of n such that in starting, like it is an arithmetic progression with first term 13, second term 19, that is common difference 6 is should always be less than, that is nth term. Nth term is a plus n minus 1 into d, number of elements, into d is 6, less than or equals to 100. Less than or equals to 100. So 13 plus 6n minus 6 less than or equals to 100. 13 minus 6 is 7. So 100 minus 7 is 93. N less than or is equals to 15 point something. That means n is equals to 15. So number of elements in this particular set are 15, friends. Okay. Next question. Let lambda belongs to R and the set of and the equation EB mod x whole square, mod of x square or mod x whole square is same, friends. So mod x square minus 2 times of mod x plus lambda minus 3, mod of lambda minus 3 is equals to 0. For that what I am doing is add 1, subtract 1. Okay. Add 1, subtract 1. So why? To see this can be completed as a square, friends. This can be completed as 1 square. So this we can write it as mod x minus 1 whole square plus mod of lambda minus 3 minus 1 is equals to 0. Now clearly, friends, they have given x is an integer. X is an integer. If x is an integer, mod x minus 1 is also an integer. Okay. If mod x minus 1 is an integer, that means mod of lambda minus 3 minus 1 is also an integer. So lambda minus 3 is also an integer only now. Clear? If this belongs to Z, implies this also will be an integer only. Now, integer means when will it be satisfied? Mod x minus 1 whole square plus lambda minus 3 is equals to 0 means this can be either mod x minus 1 either equals to 0 or either equals to 0 or mod of x minus 1 is equals to either 1. Because if this is 1 minus 1, then lambda minus 3 will be integer. Clear? Why? Because mod of lambda minus 3 is equals to 1 minus of mod x minus 1 whole square. That means this should always be greater than or equals to 0. Why? Because mod. So lambda mod x minus 1 whole square minus 1 is less than or equals to 0. Mod x minus 1 less than or equals to 1. That means either it can be 0 or 1. Either it can be 0 or 1. Okay. Now see this, friends. Either it can be 0 or 1. So mod x minus 1 is equals to 0 or mod x minus 1 is equals to 1. If mod x minus 1 0, so mod of that means from here mod x is equals to 1, which implies x is equals to plus or minus 1. From this case, mod x is equals to 2 implies x is equals to plus or minus 2. Clear? Now if x is plus 1, what about lambda? If mod x minus 1 0, in this case, if mod of x minus 1 is 0, friends, then mod of lambda minus 3 minus 1 should be equals to 0. So this should be equals to 1. Lambda minus 3 1 means lambda minus 3 is equals to plus or minus 1. So lambda is equals to minus 3 plus 1, that is 4, or minus 1 plus 3, which is plus 2. Clear? Next, if mod of x minus 1, if this is 1, then for sure lambda minus 3 should be only 0. So lambda is equals to 3. Okay? So now what we need? X plus lambda. X plus lambda. X plus lambda. In this case, if x can be either 1 or minus 1, 4 plus 1 or 4 minus 1, 2 plus 1, 2 minus 1, 3 plus 2, 3 minus 2. Among all of them, what is the maximum? X plus lambda. Largest elements in the set we need. That is x plus lambda. What can be the maximum value of x plus lambda? Which is 5. Answer is 5. 4 plus 1 or 3 plus 2. In these two cases only we are getting the maximum. Among all, less than 5 only. So the largest element in the set is 5 itself. Next question. Set A given, set B given, then the number of elements in C subset of A such that C subset of A means sample space will be, total number of subsets will be 2 power 7. 2 power 7 is 128. There will be total 128, friends. Now C subset of B, now we have to take C subset of B such that we need not equals to 5. For that we do one thing. C intersection B is equals to 5. Let's take the set of elements of C such that C subset of B is equals to 5. That means for sure C should include what are all the elements that C should include? Subset 5 means 1, 2, 3 we have, 4 we don't have, 5 we don't have, 6. That's it. So C should take 1, 2, 4, 5. 1, 2, 4, 5 such that C intersection B is equals to 5. So number of subsets, if C takes the elements 1, 2, 4, 5, number of subsets of C that we can, number of subsets of A that we can get is 2 power 4, which is equals to 16. So from total 2 power 7, this 2 power 4, only these subsets will be having 1, 2, 4, 5. And if these subsets are included, C intersection B is 5. Now to make C intersection B null set, not equals to 5, that means number of elements will be 2 power 7 minus 2 power 4, that is 128 minus 16, which is clearly 112. 128 minus 16 is 112, friends. Clear? The answer is 112. Next question. Coming to this case, let S is equals to set of 4, 6, 9, T is equals to 9, 10, 11 and so on 1000. Then set A is equals to A1 plus A2 plus and so on AK. K belongs to N such that A1, A2, A3 and so on AK belongs to S. See friends, now set A is indicates if K is 1, set of only one, sum of only one element, that is 4, 6, 9. If K is 2, 6 plus 4, 10. Yeah, say 4 plus 9, 13. Next 4 plus 4, 8. 6 plus 6, 6 plus 6, 12. 9 plus 9, 18. And so on we get many number of elements, okay, such that these all elements will always be of the form 4x plus 6y plus 9z such that x comma y comma z belongs to z and x y z greater than or equals to 0. greater than or equals to 0. Okay, but not 3 should not be 0 at the same time. Okay, so now if you see this, friends, in t you got 9, we have 10, 11 chhod do, 12 we have got, 13 we have got, 14. When do we get 14? When do we get 14? When do we get 14? 6 plus 4, 10, 10 plus 4, 14. Okay, if you add 2 4s and 1 6, we are getting again 14. So 14 is also included. Next 15, 9 plus 6 is 15. If you see this, if you observe this, every number in t can be expressed in the form 4x plus 6y plus 9z, friends. Each and every number in t expressed in the form of 4x plus 6y plus 9z except this 11. However, you add 4, 6, 9, we will never get 11. So that means in a, that means t minus a, when you exclude, there exists only one element called 11. Only one element, which is 11. So now they are asking sum of all the elements in t minus a. That is only one element. So the element itself. The answer is 11. Answer is 11. If they ask number of elements in t minus a, answer is 1. Now they are asking sum of the elements in t minus a, which is 11. Next question, the last question, friends. Let S is equals to set of x comma y belongs to n cross n. 9 of x minus 3 whole square plus 16 of y minus 4 whole square is less than or equals to 144. Clearly this is an ellipse, friends. Ellipse. So the ellipse is x minus 3 whole square divided by 16 plus y minus 4 whole square divided by 9 is less than or equals to 1. Friends, you know, expressing the ellipse in standard form, let's take this x minus 3 as some capital X, okay, and y minus 4 is equals to some capital Y. So we get x square by 16 plus y square by 9 less than or equals to 1. Sir, by this what do you get? I'll get an ellipse in standard form. It's easy for me to express in standard form, friends. Okay, let me draw an ellipse. Let me draw one ellipse. Okay, this ellipse has center 0, 0 and intersects x-axis at point 4, 0 and minus 4, 0. Okay, now we have also one more thing. What we have? We also have circle. This circle is x minus 7 whole square plus y minus 4 whole square. Already x minus 3 is capital X, no? I can write this as capital X minus 4 whole square plus y minus 4 is any capital Y square less than or equals to 36. A circle with center 4, 0 and radius 6 units. Radius 6 units. So for sure this will be like this. This will be like this, friends. Center with 4, 0. Let's take this like this. Center should be 4, 0. As I am not getting space, I am just moving it here. Okay. So 4, 0, radius is 6, no? So for sure this intersects this at minus 2, 0. Now what are all the points that we need? S intersection T means, friends, S intersection T means these points we need. Set of all these points such that integral coordinates, only integral coordinates. Now let's see this. If x minus 3, x is a natural number means x can take 4, starting with if x minus 3 is equals to capital X, so capital X can take x takes 1 minus 2. If x takes 2, 2 minus 3 minus 1, 0, 1, 2 and so on, because x should be a natural number, no? So if x takes 1, 1 minus 3 and so on. If y takes 1, 1 minus 4 minus 3, minus 2, minus 1 and so on, something. See friends, this ellipse intersects y-axis at a point 0, 3, 0, minus 3. Now all the points which lie inside this ellipse and circle we need, okay, those points. Now clearly we'll see what are all the points. First, if y is 0, we take coordinates -2, 0, -1, 0, 0, 0, 1, 0, 2, 0, 3, 0, and even 4, 0. All these points lying inside or either on the curve. Okay, how many points we have? 1, 2, 3, 4, 5, 6, 7. We have got 7 solutions in this case. Suppose if y is 1, see -2, 1 will be lying outside. So -2, 1 won't be. We can have -1, 1, -1, 0, correct? -1, 1, sorry, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1 will be lying here. So we are not including 4, 1. That means 1, 2, 3, 4, 5. We have got 5 solutions in this case. In similar way, if y is -1, same -1, -1, 0, -1, 1, -1, 2, -1, 3, -1. We get again 5 more solutions. Okay. Next, if y is 2, -2, 0, sorry, -2, 2 will be somewhere here. What about -1, 2? -1, 2. We'll check, friends. -1, 2 will lie. If we put -1, 2, it should lie inside the -1, 2 means 1/16 plus 4/9. 1/16 plus 4/9 means 9 ones are 9 plus 16 fours are 64. 16 nines are 144. Yes, it is lying less than or equals to 1 only. So that is, if y is 2, -1, 2 will lie. -1, 0, 2 will lie. 1, 2 will lie. What about 2, 2? If we put 2, 4/16 plus 4/9. 4/16 plus 4/9. 9 4s 36. 36 plus 64 less than or equals to 144 only. So even 2, 2 will also lie. 3, 2, 9 9s are 81 plus 64. 81 plus 64 will be no. So only this 1, 2, 3, 4. 4 points we have got. When y is equals to -2 also we get same 4 points. Okay. Now till now we have got 7, 10 plus 17, 17 plus 8, 17 plus 8, 25 we got. Now if y is 3, we get only 0, 3. If y is -3, again 0, -3. So 25 plus 2, total 27 solutions we get, friends. 27 solutions. That means in S intersection T with integral coordinates, we will be having 27 points which lie inside this. This is the region. Inside this region, we will be having 27 solutions. Clear? So with that, we are done with all the questions from the chapter sets from previous year JEE Mains 2024, 2023 and 2022. For sure this will support you, my dear friends, and for sure this is going to boost your preparation like anything. Make sure you watch each and every question solution thoroughly and practice good number of questions including PYQs and some other miscellaneous. Okay, see you in the next session. Till then, all the very best for your preparation. All the best.